So 1,000 pounds of wood goes into here. You use the propane over here to turn it on. It takes about 15 gallons of propane to get the process started. And then this is gonna come up to temperature, about 300, 350 degrees centigrade. Once all the water is evaporated out of that wood, there's something called syngas, right? So it's like methane and some other combustible gases. Like that's what lights on fire when you light wood on fire. Once we hit that point, the syngas is recirculated through this, this condenser on the back. This is basically like a gigantic pit boss, right? It comes under and then it ignites, and then we can turn off the propane, and it's just parasitic, and it just kind of burns itself out, and it kicks up to about 500 degrees centigrade, and it cooks, right? So the chemical reaction that's happening, it's called well, I guess not chemical, it's thermo separation. So you're cooking at a high temperature with no oxygen. And unlike combustion, that's gonna have a chemical reaction and destroy everything, what this allows us to do is separate all the constituent parts, send them into other places, and then refine those and sell them as like industrial scale chemicals and materials. So what comes out? So 1,000 pounds of wood, I'm sure like it's carbon, it's black stuff. So what comes out is essentially like a lump of charcoal. So what you'll notice here, it's kind of shiny, is softwood is really, really great for this because it has low ash content. So ash content is like that white stuff or silvery stuff you might see in your fireplace. That's gonna be impurities in that piece of wood. So if you're using hardwood, it's gonna be like lead, zinc, cadmium, mercury, heavy metals, all kinds of stuff. Now, it takes extra energy to purify that stuff out. Same thing with mined coal. If you mine coal out of the ground, it's got a bunch of junk in it. The biggest benefit for industry is that this is high purity, which means it's just a better base product. So this can get upcycled into batteries and high-end graphitization type purposes because it has such great purity. And we don't have to waste a lot of energy removing those impurities. The other thing that's gonna come out is you can see these ports here in the front. So there's one down here and there's one off the back. So as the liquids separate, they're gonna flow out there. They're gonna go into a distillation set, and we're gonna separate the water, which is a vinegar, it's an acid, from the tar, which winds up being like a viscous tar. So what do you use the tar for? Oh, so we got here, so 1,000 pounds of wood, 30% of this, so about 300 pounds of carbon comes out. You're gonna get, these are 5-gallon drums, 5, 10, 15, 20 gallons of the vinegar, and 5 gallons of the tar. So you can see here, this machine right here, this is, you can see all this damage. So when this thing gets hot, this paint basically just burns off, right? And it rusts because we're outside. But the tar has already been heated to 500 degrees centigrade. So we burned out off the VOCs and PAHs and PCBs. And what we wind up with is a high temperature coating and sealant that's anti-corrosive, weather protective, and has no oxygen separation. It fills in the microscopic pores. So all this black stuff here, we just painted our tar on top of the metal, and this prevents our stuff from rusting. You can also put it on the inside as well to get some coating to prevent corrosion. What we're really excited about this is for a base layers on automobiles and boats or undersides of bridges. So C-SPAN, not the television network, but SEA-SPAN, is the largest privately held container ship company, I think, in the world. So they spray coat their ships, like 2-3 ships every day, about 1,500 liters of spray coating. They want that tar as the base layer coating for their ships, and they've already told us they want 500 liters a week just to start. That's just one buyer. 500 liters, about 135 gallons. So that's just one company, and they would take all that they can get. So this, you can see, it's really nice when it got put on. It's nice and black and shiny, but so this, you could also turn it into a concrete sealant. So if you want to seal your concrete foundations in our moist climate up here, very difficult to do, it turns out, especially with natural products. So we've had a construction firm already purchase this to do sealing the concrete foundations, And they love it because unlike other sealants where it kind of sits on top, it will actually soak into the microscopic pores of the concrete and fill the cracks. So you're not gonna get moisture in the concrete, which is gonna cause microbial growth, and that microbial growth is gonna crack your concrete. It's also gonna help with that freeze-thaw cycle, where you get cold and hot. It's gonna help resist that cracking on the internal pressure of it. The last thing we're gonna get is this vinegar. This is called pyroligneous acid. You go on Google right now, it sells for about 80 bucks a gallon. It winds up being an excellent biofungicide, biopesticide. It winds up actually making your plants grow faster, which is super cool. We spray it on our trees. We have about 100 apple trees in an orchard or a farm. And then Steve over here did another test where I think he had rotted apples last season and used neem oil in our vinegar and successfully had apples without worms. Apple maggots, yeah. Or without apple maggots. So for our cash crops here in the state of Washington, whether it's cannabis or it's apples or it's pears, there's a really, really big problem with managing the pest cycle. Up to 40% of those trees just die every year. And with these products, we're actually able to treat and even save trees that would otherwise be mandated to get cut down and burned because they couldn't do anything with it. As we move up the chain, the wood vinegar can be essentially fractionalized down into acetic acid and some other cool stuff. Winds up being a really excellent curing agent for concrete. It's a plasticizer. So we're using this right now as part of our concrete formulation. And then Clay will tell you other magical stuff that it does. But really where we want to be at the higher end is in plastics and batteries. So we'll get to more of the science thing in a minute, but our vision, or at least what I'm seeing is the high probability we can make true, is we could work with builders and every piece of that property our products could go into. It could go into the soil and the ground for remediation of that soil and to increase water retention. It can help with the stormwater runoff and otherwise keep that property doing what it should be from a pH and chemistry level. Our products can go into the concrete, the sidewalks, the driveways, the foundation. Someone like Richard, who's doing other materials, we can have insulation, boards, other organic materials inside of it. And then the battery system that you would have at that house for the on-site battery storage, our carbon would go in that as well. So it could be a net zero home, an energy freedom home, or a circular bioeconomy home, whatever you want to call it. But we think that the buildings of the future will be made from materials sourced right here in Lewis County. So that's the technology. Why don't we go inside and I'll have Clay. Hey, Jake,
yes. What's the cycle time?
Yes.
For one batch of 1,000 pounds?
Great question.
5 to 6 hours.
So the way that this works is this is batch loaded, and it takes about 5-6 hours to go through the whole process and exhaust the syngas. And then, depends, it's gonna take between 4 and 6 hours for the cool down cycle. So we're working on shortening the cool down cycle. We're gonna, lift the gate, get some heat recapture, you get fans under it. But the goal would be on a 24-hour shift to run 2 cycles. So 2,000 pounds per machine per day. The OEM that makes this, they make a bigger version of this that's a vertical batch load. What was that? Cool. Instead of 1,000 pounds per run, it's 3,000 pounds per run. Same operating budget, but the big difference is that it's, imagine like a deep fryer. It's an enclosed tube. So you just kind of pick up the tube and drop another one in. So you don't have to go through the cool down cycle anymore. You can just keep it running and then just let it cool down in the tube, and you just kind of keep moving tubes in. Then at the industrial scale, this is gonna, it's like a $20 million machine instead of a $10,000 machine. It's like, 40 feet tall. It's got a dryer stacked above it. We recapture the waste heat for the drying. And then it's got like a big fucking rotary drum that just, shoves in 180 tons a day of material. And that needs like a 50-foot building, 10,000 square feet. So that's gonna be a big industrial size. It's gonna take a while. This has no electronics, no moving parts. The only permitting is that thing over there. And then the SWACA, the Southwest Clean Air Agency, for our emissions permit. That's it. We've already talked to SWACA. They've come and watched us. They were here for 2.5 hours last time we had them, gave us a ton of suggestions, and they're very, very active right now in helping us get our permit.